Episode 1 Science. How it all ends. A light-hearted exploration of the depths of the universe serves as an effective antidote for everyday worries, by Paul Halpern. In these challenging times for us, the notion of exploring and inhabiting other worlds is enticing. After all, if someday humanity's existence on this planet appears threatened, we might continue civilization elsewhere, assuming we have the technology to do so. Yet, as astrophysicist and popular science communicator Katie Mack shows in her excellent, far-reaching debut book, the end of everything, astrophysically speaking, at some point the entire universe's luck will run out. In clear, succinct prose, Mack details 5 different ways the cosmos might end. For the first possibility, the Big Crunch, she posits that the universe's expansion will reverse itself into a lethal crash that manifests as collisions between neighboring galaxies. In this scenario, she argues, the Milky Way will crash together with astronomy, and all stars will suddenly be jolted from their orbits, while elsewhere hydrogen gas coalesces and ignites to form new stars. The Sun, by then, a swollen red giant, will have subsumed our mother planet. Meanwhile, many such collisions will occur between numerous other galaxies, until all of space has been condensed back down to a single highly compressed, potentially infinitely dense glob. Scary? Very much so. She reassures us, however, that mounting astronomical evidence indicates that cosmic collapse is very unlikely. Before we can breathe a sigh of relief, Mack reveals a second scenario that might be even worse for the universe than the first: the space-stretching effects of dark energy. An abundance of observational data indicate that an unknown agent is accelerating the expansion of the universe, driving distant galaxies farther away from our own at a faster and faster rate. What is not known yet is how that dark energy behaved over time. Some models endow it with greater potency than others. Albert Einstein once added a fudge factor, known as the cosmological constant, to the equations of general relativity to artificially induce stable solutions. At that time, he did not believe in cosmic growth or shrinkage. Once Edwin Hubble revealed evidence of the recession of galaxies, which was in agreement with Georges Lemaitre's theory. Earth, an expanding universe. Einstein decided to eliminate the term. However, Einstein may have been right to include such a constant after all. Although dark energy could well be volatile, most astronomical observations indicate that it is relatively steady, conveying a rate of accelerated expansion that is comparable to what is predicted when a cosmological constant is retained in the relativity equations. If the universe were to succumb to dark energy-induced expansion, an increasingly rapid stretching of space would eventually isolate us from the bulk of the universe. Over the eons, all stars will burn out, resulting in a lack of usable energy, a scenario called heat death. But what if dark energy turns out to be even more potent than cosmological constant, overcoming every possible form of attraction and rendering everything unstable? Mack devotes perhaps the most frightening chapter of all to this scenario, known as the Big Rip, in which everything, including space itself, is torn apart into shreds. In the chapter that follows, she explores yet another kind of cosmic catastrophe, This one triggered by changes on the quantum level of the vacuum state of the universe. Like a frozen river that permits skaters to frolic along its surface, the vacuum state supports the particle dynamics that make life possible. But just as rising temperatures might cause chunks of ice to break off and melt, unexpected cosmic conditions might suddenly disrupt the vacuum state, alter the masses of elementary particles, and think the particle world. The final and presumably most optimistic scenario that Mark describes is a cosmic bounce, which at least permits the prospect of new worlds after an interval of universe destruction. The basic idea is that the cosmos will experience endless cycles of devastation and rebirth. Having completed her PhD thesis on the Paul Steinhardt, the co-originator of one such model called the epirotic universe, she is the ideal writer to convey the theory's premise, and describe it well she does, drawing upon a clever analogy that involves hands clapping together and joint apart. All in all, the end of everything serves as an outstanding, level-headed guide to horrific medley of ways the universe might expire. The book is the perfect antidote to the malaise of mundane worries.